We've always been told that space is a vacuum, right? Just this huge, unending silence. But what if that's not quite right? What if the universe is actually humming with a sound we just can't hear? And what if the greatest mystery isn't its silence, but who out there is choosing to stay quiet?
Because here's the thing, space isn't silent at all. It's actually buzzing with energy. Radio waves, X-rays, you name it, all being thrown off by stars and black holes. Our instruments can pick all this up, and scientists can basically convert that data into audio that we can actually hear.
And honestly, some of these sounds are pretty unsettling. Take a listen to this. What you're hearing is the sound of a supermassive black hole at the center of the Perseus galaxy cluster. NASA took X-ray data and scaled it up by 58 octaves. That's 288 quadrillion times higher than its real frequency, just so our ears could pick it up. It's this low, haunting moan from 240 million light years away. When you hear that, it is really hard not to wonder what else is making noise out there. And it turns out that very same question was asked over lunch way back in the summer of 1950 by the legendary physicist Enrico Fermi. He was just looking up at the sky, thinking about the mind-boggling scale of the universe, and he asked this simple, profound question that has haunted us ever since. Where is everybody? And that question became what we now call the Fermi Paradox. The logic behind it is just so simple. I mean, our galaxy alone has hundreds of billions of stars. We now know most of those have planets. A good chunk of those should be able to support life. So with billions and billions of chances, life should be everywhere. So why, when we point our telescopes to the stars, do we get what scientists call the Great Silence? For decades, that silence was deafening. It was almost absolute. But then, on one quiet summer night, something broke through. A single powerful clue in our cosmic detective story that, for nearly 50 years, nobody could explain. August 15th, 1977. A radio telescope called the Big Ear is doing its thing, just scanning the sky. And suddenly, it picks up this incredible signal. It only lasted for 72 seconds. It came from the direction of the Sagittarius constellation, and it was printed out on a sheet of paper as this simple cryptic code, 6EQJ5. We had never, ever seen anything like it. Now, this code, it actually tells a story. Each number and letter represents how strong this signal was. It started strong, then it got even stronger, E, Q, until it hit its peak at U, which was more than 30 times stronger than the normal background noise of deep space. And then just as perfectly as it arrived, it faded away. It was a perfect bell curve. Back then, absolutely nothing in nature was known to make a signal like that. And this is where it gets really crazy. The signal was broadcast at exactly 1420 megahertz. Okay, so what? Well, that's what's known as the hydrogen line. It's the frequency that hydrogen atoms, the most common element in the entire universe, vibrate at. Astronomers had been saying for years that if an intelligent species wanted to send a "we are here" message, this is the universal calling card they'd use. It was clean, it was focused, it was powerful. It looked artificial. So the first thing investigators had to do was rule out all the usual suspects. See, signals from things like pulsars or black holes are messy, they're noisy, and they're spread out across a ton of different frequencies. The wow signal was the exact opposite. It was like one single, clear note in a universe full of static. For half a century, it was the best piece of evidence we had that we aren't alone.
Until, maybe now. There's a brand new theory that might finally solve this thing. Using some serious computer simulations, researchers figured out a way a natural event could have perfectly faked the signal. The idea is that a massive blast from a special kind of star, a magnetar flare, shot through a passing cloud of hydrogen gas. This would have supercharged the cloud, making it light up like a giant cosmic light bulb and, you guessed it, emit a powerful, focused burst of radio waves at exactly 1420 megahertz for about 72 seconds. The 50-year-old mystery might finally have an answer.
And that whole story perfectly illustrates the challenge, right? We spend all this time listening, trying to pick a meaningful sound out of all that cosmic noise. But some scientists are getting tired of waiting. They're saying, hey, if we really want to break the great silence, we can't just sit here and listen. We need to shout. And that's the whole idea behind something called active SETI, or METI. It stands for Messaging to Extraterrestrial Intelligence. The idea is to stop being so passive about this whole thing and to start actively beaming our own messages out into space. basically to announce to the cosmos, hey, we're here, you are not alone. And look, this isn't just some theory from a science fiction movie. We've been doing this for decades. We sent the famous Arecibo message back in '74, more recently the sonar calling message in 2017. And get this, some of these postcards are actually set to arrive pretty soon. The one we sent to Luton Star, it's scheduled to get there in 2030. Yeah, just a few years from now. But this whole idea of shouting into the void, it raises a really terrifying question. What if the reason the universe is so quiet isn't because no one else is out there? What if it's because everyone else is smart enough to hide? This is the core of one of the most chilling explanations for that Fermi paradox.
The science fiction author Liu Cixin put it perfectly in his novel. He wrote, "The universe is a dark forest. Every civilization is an armed hunter stalking through the trees. If he finds other life, there's only one thing he can do: open fire and eliminate them." It's just a powerful, disturbing image that's hard to shake.
And the logic behind it is, well, it's terrifyingly sound. It all starts with one simple idea. Survival is the #1 goal for any civilization. But since you can never, ever be sure about the intentions of some other civilization millions of miles away, and since they could be a threat to your very existence, the only truly safe, logical move is to eliminate any potential competition before they can do the same to you. And the conclusion? The universe is quiet because the only ones left are the ones who learned how to hide. So this brings us right to the heart of this huge debate. On one side, you've got critics like the great Stephen Hawking, who flat out warned that trying to contact aliens is foolhardy. He looked at our own history and basically said we should just lay low. But on the other side, you've got people like Seth Shostak, who argue that these fears are all just hypothetical. I mean, what if an advanced civilization could give us knowledge to save ourselves? Why should we endlessly tremble at the sight of the stars? So here we are, stuck at a cosmic crossroads. And as our own technology gets better and better, the choice of whether we should shout or hide becomes more and more urgent. Because the truth is, we are already getting louder, whether we mean to or not. Let me throw a number at you. 5,753 miles. Okay, what's that? Well, that's how far beyond the far side of the moon NASA's upcoming Artemis 2 mission is going to travel. It'll be the farthest any human being has ever gone from home. With missions like Artemis 2, we're not just sending radio waves anymore. We are physically stepping out into the dark. We're pushing our actual presence deeper into space, and in doing so, we're becoming a more noticeable, more detectable civilization. We're basically turning on a small light in that vast, dark forest. Which leaves us with the ultimate question. Maybe the Great Silence isn't a mystery we're meant to solve, but a warning we're meant to listen to. In the dark forest of the universe, do we keep sending out sparks, hoping to find a friend? Or do we hold our breath, put out our fire, and just hope that whatever else is out there, listening in the dark, doesn't see us? The choice, it seems, is ours.